All right, hello students. Today we're moving on with lesson 15, read expressions in which letters stand for numbers. So we can talk about these things called variables, where letters represent numbers, and we can continue kind of on that path today. So here it says, opening exercise, complete the graphic organizer um, with mathematical words that indicate each operation. Some words may indicate more than one operation. So if you look down here, we have our kind of we have our operations, addition, subtraction, multiplication, division, and our exponents, which of course is repeated multiplication. So we're going to kind of talk about or go over some words that represent each of these. Um, so if we start over here with addition, we have talked about a few different words that represent addition, but if we continue kind of going through our list, here's a few more words, or here are words that represent addition. So if you need to, pause the video real quick, go ahead and write these down. Otherwise, I'm going to kind of talk with you about them as you're kind of writing them down. First, the sum we've talked about, of course, is the answer to an addition problem. We add more than total, of course, total, hopefully you've seen before. All together, in all, and increase by, and of course, the word plus. So if you need to memorize, I'm going through these, go and pause the video as needed and fill them in. Next, we're going to move on to subtraction. In subtraction, here are some words that represent subtraction. We have difference, of course, the answer to a subtraction problem. Subtraction, fewer than, minus, less than, how many more, left, and of course, decreased by. And remember, these two right here, I'm going to kind of underline them, fewer than and less than means you have to actually switch the numbers around or switch the terms around. Because of that word than. Now, if you switch this around on the more than, that would work as well, because addition, it doesn't matter which way you add. It's called the commutative property of addition. If we continue going through, we go to multiplication now. We have product, of course, the answer to a multiplication problem. Multiply, times, even, excuse me. Double and triple, these are kind of more specific. This means 2 times. This, of course, means 3 times. Of, as much, and each. The word of actually does mean multiplication, so you have to be kind of look out for that and be aware of that. The next word, division. Here are some words that represent division. We have quotient, of course, the answer to a division problem. Divide, each, per, and split. Remember, each. How many does each student have? That's kind of representation of division. We're we're going to split it into so many groups. Things like that represent division. And the last one, exponents. Of course, we have power, we have squared, and we have cubed. I'm going to kind of go ahead and write this down. If you have squared, this means to the second power, like a square is a 2-dimensional figure. The word cubed, remember, means to the third power, because a cube is actually a 3-dimensional figure. That's kind of where they get these from. So there you go. All right, so if you need to, remember, pause the video and go ahead and copy these down. Of course, these are not all the words you could possibly see. These are just kind of the most common ones that we see as we move on. All right, so let's go over just kind of a couple examples. This is write an expression using words. So we're going to take these, of course, and we're going to use phrasings or words to represent them. So if we look at the first one, of course, this is a subtraction problem. You could say this, of course, several different ways. Let's go ahead and kind of just talk about a couple. A is the first variable. We could say A minus B. I'm going to put down just kind of a couple of these for these to kind of show the difference that we could use. Speaking of difference, we could say the difference of A and B. Oops, gotta spell it difference actually correct. That would help. Of course, using the answer to a subtraction problem. And let's kind of go over one more. Let's go ahead and put B subtracted from A. Okay, now if we remember, subtracted from A, B is being taken away from A. So that's why we put B is subtracted from. So that's why I like to throw that out there. It's kind of, this is another one actually not on our list. At least I don't think it was. Let's go back real quick. Subtracted, so subtracted from. So that is one that we actually have to switch these around as well. All right, so if we go into the next one, we could, once again, we're going to go over a few of these. We could say x times, I mean, let's go with an easy one, x times, well, since this is a lowercase x, we want to make sure it's a lowercase x as well, x times y. It's kind of an easy one. How about the product going on with our of x and y, going with the answer to the problem? And let's go ahead and just talk about one more. Um, just how about x multiplied by y? There you go. So those are kind of three different ones for each of them um, that you could use that actually work. Um, there's actually a whole bunch of varieties that we could actually come up with. All right, go ahead and stop the video. We're going to move on and kind of do a few more and kind of talk about some other things we're going to see. All right, hello students. Here are some more examples we're going to kind of talk about, discuss. These ones are a little bit more complicated because, as you can see, there are more than one operation, unlike the previous video. So if you want to give these a try on your own, I suggest that you actually watch what I do first. At least I'm going to do one of them, and you can always try to write another one to see if it makes sense. Um, that way, you're getting the practice with me, plus you're trying it on your own. So if we look at this one, this course, if we just read it, it says 4 times f plus p. If you kind of read it to yourself, you're actually coming up with the words themselves. That's kind of the easiest way to do this. 4 times f and then plus p would be um, an appropriate answer because the multiplication has to come first in order of operation, so that has to be done, and then the addition. So that would work. If you look at the next one, um, if we read this, it says d minus b cubed. So once again, I just read it to you. That's an easy way to kind of come up with them. Just simply kind of read it to yourself. This says d. This, oops, just go and put that down. This says minus. Now you can't say subtracted from because that would have to be on the other side. D minus, and then of course we can say b, oops. And we could say we could say to the third power if you wanted to say that. Or we could just say cubed. Now I'm going to go ahead and I'm going to write another one for this one just because I think this one is interesting because of the exponent. Um, so let's go ahead and kind of try something else. We could say b to the third power subtracted from, kind of going off what we had before, subtracted from d. So kind of writing it backwards. Remember, this is not d subtracted from b to the third power. This is b to the third power is being subtracted from d. It's almost like you have to read it backwards. So let's see, if you want to try to write another one of your own, go ahead. Otherwise, we're going to move on to the next one. If we look at this, now this one is a little bit more challenging because we have the parentheses here. If we read this, it says 5 times parentheses u minus 10 and the parentheses plus h. Well, you can't say beginning of parentheses, end of parentheses. That's not telling us what's going on. What you could say is 5 times the difference of u and 10 plus h. So if we kind of wrote it like that, that's what it's saying, 5 times the difference. Now we're using the word difference because we have to find the answer to the subtraction problem first. The difference, oops, didn't spell that right. Let's go and get it done correctly. The difference of u and 10, and then of course what happens at the end, plus h. Oh, not 10, but h. This is saying that I have to find the answer to the subtraction first and then follow order of operation. Then I can multiply and then I subtract. So that works. Once again, if you want to try another one on your own, go ahead and try it. See if it makes sense to you. If it does make sense, or if you want me to come by and look at it, that's fine as well. But think about kind of what makes sense. And now on this one right here, we have 3. This is being divided by the sum of, or h plus f. Remember, you have to find the answer to this bottom first. This is almost like having this in parentheses, kind of like this one is up here. So we could say 3 divided by the sum of, because we have to find that answer. Whenever you see these parentheses, you have to use the answer word to that operation. So since this is subtraction, we would use difference. Since this is addition, we would use sum. So we could say 3 divided by the sum of D and F. Okay, there are several different ways you can do it. Once again, if you want to try one on your own, go ahead and do so. But these are just some examples of kind of what you could see or what you would want to be pulling out from it. There's not any kind of parentheses. You really could just simply write them as they are if you just read it to yourself, like on these two up here. But when the parentheses come in, you have to use kind of these more specific words of the answer to an addition problem or the answer to a subtraction problem before you do the other operation, because order of operation is important and must still be followed. All right, so if we kind of move on to the next part, the next part you're going to have is you're just going to simply kind of identify. This says circle all the vocabulary words that could be used, not that need to be used, but could be used to describe the expression. So if we're looking at this, what we're going to do is kind of look at this and which one of these actually could be used in this expression if we used words. So all we're doing is circling them. So over here, it says addition. Is there an addition going on in this expression? The answer is no. Is there subtraction? Absolutely. So we would circle it. So here's our subtraction sign. Is there multiplication? Yes, there's multiplication going on because this is 6 times h. Is there division? No, there's not division going on, so only these two would be circled. All right, so what I would like you to do now is I want you to pause the video. I want you to try these on your own, try to answer them or try to come up with all the ones that should be circled. Come back and I'll go over the answers of what you should have circled. So go ahead and take a moment, pause the video, try it on your own, come back and we'll go over the answers. All right, so for number 2, hopefully you circled the word product and circled the word quotient. There's a product going on because 5 times D, and there's a quotient going on because, remember, this division bar or fraction bar means division. All right, so we don't have sum and we don't have difference. If we look at number 3 here, hopefully we have add circled because there is addition going on here. Now we need a little bit more words than just simply add. We'd have to use the quantity of 2 added to D, but that's still there. That would still work. We have subtraction going on because 8 is being subtracted from. We have multiplication going on here because 5 is being multiplied, and there is no division, so division would not be circled. On the last one, how could we express this appropriately? This is just simply B times A times B times C. So the word times right here is really the only thing that we could use. We couldn't use the word each, even though each sometimes can be used for multiplication. We couldn't say, we couldn't, it would be very tough to use this in a phrase with all 3 of these. The word each really is that each group has, there's 2 groups. Each group has 5 marbles in it. How many marbles do we have all together? Well, that each would represent multiplication. We really couldn't use that with this one because of the multiplication problem that it is. So if you wrote that, you used the right idea. At least you would look back at the list. But times really is the only one that would work here. A times B times C. All right, so hopefully you have those correct. If not, that's okay. Hopefully you correct them. Or if you have a question, please raise your hand. Otherwise, you should be good to move on to the assignment for the day.